All right, welcome back, guys. So we're going to spend just a little bit of time this week making sure that you guys have a good foundation in calculator skills and just general knowledge of how to use your calculator, so that later in the year when we need to do more advanced analysis using your calculator, we're not fumbling it up by not being familiar enough with the calculator to work creatively towards a solution. So you'll see in my OneNote there's a tab for graphing calculator tutorials, and this is what we're going to be working through. Now I've got a calculator that we'll be able to use here. As we go along with the lesson. I'll resize this, I think. Or not. There we go. Okay. So, let me take you through some just very basics here real quick, and then we'll get going. In my OneNote, you've got the document here that we're looking at, and it shows you all the key presses and gives you a lot more explanation for what's going on. So if you find something that we're going over that you need more in-depth help with, your first place to go would be to read these sections more carefully. One of the places that students fall into trouble with first, or most often, is just getting their calculator set up properly for the problem they're working on. And a lot of times we just forget that we have settings that need to be changed based on what type of problem we're working on. In this case, up here at the top, if you've got a newer TI-84, then you've got Math Print, or it might be called Pretty Print, or Classic. And if you have that option, you absolutely want Math Print, because it's going to show the stuff you're typing in the way that it should look. So that's really nice. And then we've got Normal, Scientific, and Engineering. And these are the different ways to notate numbers. So scientific notation, basically. So I see a lot of students that, like, they've got a big number on the screen. Let me quit out of this. I'm going to press second, quit. They've got a big number on this screen, and they need to turn it into scientific notation for their teacher or whatever it is, and they're adding pencil marks to their screen as they count all the zeros. There's really not a need for that. You can go to mode. We'll switch into scientific. Switch out. And it's going to put that number in scientific notation for us. Now, 1E9 means 1 times 10 to the 9th. So it's a shorthand that they use. 1 exponent 9. 1 times 10 to the 9th. And so, yeah, no need to sit there and count zeros, that kind of thing. All right, so let's go back to mode. The next thing, I'm going to put it back in normal. The next thing, we can kind of ignore it. It's not really important for our class. The most important one is going to be radians and degrees. And it may seem like a bit of a mystery when you should be in one versus the other, but let me give you a hint. In our class, there are 2 times that you absolutely have to be in radians. You must be in radians when you're graphing, and you must be in radians when you're taking a derivative or an integral. Okay, so those are the 2 that we want to be most careful about. Another way to think about it would be, in this class, basically set it to radians and leave it that way, unless you have a problem that's given to you with degrees and you're doing trig. So you're taking the sine of an angle or something like that, then you might need to set it degrees if it's given to you in degrees. All right, next we have function, parametric, polar. So in this case, function is what we're going to be using most of the time. Parametric equations are covered as the AP Calculus BC test, so we won't use them at all in class. And again, if you're interested in taking the BC test as well, just email me privately and I'll talk to you about what we will and will not cover as part of our class and what you need to do on your own. A lot of this stuff we can be skipping. Now, it might be beneficial to you to set, this is how complex numbers are given to you. Maybe it only gives you real numbers, or it gives you your complex numbers in a Cartesian format, or it gives you your complex numbers in a polar format. In our class, we basically never use complex numbers, so that's not something we need to worry about right now. And there's also other stuff down here you can look at, fraction types and that kind of thing, that are less important. All right, anyway, moving on. We're going to skip through some of this. We'll get to some of it later. So let's go into the math menu. So math is right here. It has a lot of good functions for you. You can convert a number to a fraction. You can convert it to a decimal. And it's got some basic information here, like taking different types of roots, finding mins and maxes, doing a numeric derivative, numeric integrals, summations. So those are all really nice, and we'll get to them as we need them. Also, really in the number column here, we do use the absolute value operation quite a bit, so that's where that's located, so you can find that. Let's skip ahead through that. It might seem simplistic, but one of the places that I see students make mistakes the most often is just entering complex equations or expressions incorrectly into the calculator. So in this case, if we're looking at example 1, we can see we've got something that's rather complex. So let's go through this really quickly and see how we would do it. So we're going to start with that square root sign right here, and we've got 3 squared, so the squared button's right there, and minus 4 times 6. Now we can use either the multiplication sign or we can put the 6 in parentheses. That's called implied multiplication. The T84 does implied multiplication, the T89 will not, so just be aware of that. Now, the notation in the book here has them alternating square brackets and parentheses, or rounded brackets, and that is the convention that mathematicians use to help things look nicer and be more easily decipherable when looking at expressions that involve a lot of parentheses. Your calculator does not like you using square brackets in that way, so you will just need to do rounded brackets. So we're going to have 5 minus, and then this is a negative sign here, not a minus sign, so we're going to do negative 12, and then another closed parenthesis, and then to the third. So we're going to use the little up arrow there for exponent and type 3. Now we're going to press the over arrow enough times to get out of the square root, and divided by 6, and that'll give us our answer. So we do that real quick. Okay. So in this next example, we're going to talk about storing values. This is going to help you quite a bit on the AP Calc test. If you have a value that has several decimal places or is rather complicated, if you're typing it in manually over and over again, you're opening yourself up to error, clerical error, you just copied it down wrong, and rounding error. If you get lazy or you run out of time and you decide to round it and you round it by too much, you may find that all the work you did doesn't help you identify what is the correct answer. So storing variables is going to be very useful. So let's look at a couple of different ways we could store a variable. Let's say that we have, in this case, let's look here at example 2a. We can take the value 4 and store it into the variable a. So we're going to press 4 store this STO right here. This is store, and it gives us that little arrow to the side. And then we can press alpha A. And that's going to store the value 4 into the variable a. So now, if I were to type 4 times a, I'll get 16. So that works out really well. Now, something that they don't show you in this example is you do want to kind of clean things up when you're done. You don't want to accidentally be using values for variables from old problems. So one thing you can do is you can press the vars button here, and we can look for, oh no, sorry, it's not in vars, it's in mem. So we're going to go second mem down here, and then we should be able to find a list of our variables in mem management all. We've got a couple lists here, and then we can see I've got some variables A, D, E, Y1, all kinds of stuff going on here. So these ones in brackets here are matrices, and here is my variable A that we stored just a second ago. So if I press delete on that line, it'll go away, and then let's see what happens when I press A now. So A, 0. That's going to be our default. If we have no value assigned to a variable, the calculator automatically assigns the value 0. So you got to be careful with that. Just know how the calculator behaves and you'll be fine. Okay, let me show you something else that's very useful. Let's say that we have a graph. Here's a complicated graph. Let's take a look at it. All right. And I'm going to press the trace button. Now I can move my cursor around the graph, and let's say there's something interesting about the graph that I'm hoping to point at here, so maybe it's like right there. And I'm going to leave my cursor there and exit the graph. So I'm going to press second quit. Let's go to alpha y and see what value it gives me. 0.3431313949. And if we go back to the graph where we had traced, oh, sorry, yep, there we go. That is the y value that is there currently. So when you're moving around the graph, the cursor around the graph, it's automatically storing those values for you. So if I needed to do some manipulation, like let's say I need to take that y value and square it, then I don't need to write this down. I don't need to memorize it. All I need to do is quit out of the graph. Oh, sorry. Quit out of the graph. And I can press y. So I'm going to go alpha y squared. And that gives me the value squared. So that is very, very useful in the calculator section of the test because you're saving time and you're reducing your chance for clerical error. So it's really a habit that you want to start getting into. Anyway, so we can really quickly do this example. We're going to store some of these variables. Oh, sorry. So we're going to go for store A, and then we're going to store into B, -5. And then C is 2, so we'll do 2 store C. And D, it's 2/3. It's going to help us prevent rounding. And E, -1.5. Okay. You're going to want to go on to the next video now to get the rest of this.